Okay, right here what we're doing, I was trying to do a magnetic test of electrons, and not so many electrons, but magnetism in regards to the sun. Look, can you hold on for a second? Okay, what we're doing is this, right? I have a magnet on top of a piece of floating styrofoam, right? This is a magnet, right? It's a disc magnet, a flat disc magnet, right? And what happens is this, I also have with me a compass. Here is a compass that shows us which way north and south and everything is. And remember, compasses have to be held flat in order for them to work. So here's a compass for you. My kids are totally excited about this experiment. I also have a laser. I also brought a laser. Hold on a second. Alright, and so I also brought a laser beam. Here, Taz, can you open this laser beam for me, please? Cool, thank you very much. Right here is a laser. It's bright enough you can see it during the day. See how bright it is? Ooh. Yeah, it's that stinking bright. Alright, so what we're going to do with this laser...
Let me see the laser on.
Laser on. See it right there?
Oh, right over that way.
That way, you can see it?
Yeah, okay.
Alright, cool. So there's a laser. And what I'm going to do with this laser on and all this, what I'm going to do, I'm going to measure, I'm going to point and mark on the glass which way north is, so you can see it. And after I mark it, you're going to know that pretty much in relationship to the sun. We're going to also add some salt to the water, because they say salt water is more magnetic than regular water. It conducts electricity. So a couple of tests we're going to run. I'm going to use a couple teaspoons of salt water, right? And we're going to see how that affects the one that's in the control versus the one that's in the not control. So this one's controlled. There's no wind that's be able to get it because of the plastic case. And this one here is open. It's open and you can go right to the water. So if my kids allow me to and help me, I'll be able to get this done. So I just want to show you real quick. I'm going to pause it for a second and set up the test. So my question I'm trying to figure out is how much salt is in a cup of ocean water. So let's go ahead and see what that is, and let's see how much that is. Checking on Google. Okay, there's 5.33 ounces per 8 ounce in a cup, or 0.66 or 2/3 a cup per gallon. That is 31.68 or 32 tablespoons in 2/3 of a cup. So basically all the dry salt mixes tends to be half a cup or 8 tablespoons per gallon of water. If you're unsure, seawater is salty enough or too salty, you can purchase a hydrometer which can measure specific gravity. Okay, so we got 5.33 ounces. So 5.33 ounces for 8 cups, for an 8 ounce in a cup. 0.66 or 2/3 of a cup per gallon. Alright. Okay, so Tice is going to put Tice is gonna put 4 more tablespoons of salt into the water to make the water as salty as salt water, as the ocean water is. Okay, how many is that?
That's 10.
No, you did 2 more. You did 3. That was 11. You do 1 more and that's it.
Okay.
Okay, good. Okay, so now what we're going to do, take out a little piece of leaf in there, and you're going to put a magnet on top. And we're going to check to see if the water has any magnetic pull to it. You measure it with this one and then that one. If there's any kind of like a magnetic charge to it, or any magnetic, here's our compass. I'm going to use the compass to determine if there's any like magnetism to it, okay? Okay, where's that magnet? Take this magnet, put it on top of the floaty. This floaty right here. This magnet, put it on top of the floaty. Okay, in the center. Put it in the center, please. Okay, good. Right there. Okay, good. Now this one, take this one and put it in the center of that one as well. Where's the float?
Look what you done.
Okay, so
on the other side.
okay, just even though it's okay like that, just kind of take it and let's go put it here. Okay, now put that on there. Alright. Now we're going to try and see if we can do it. We can see if we can get it to where it kind of floats in the middle, okay? Float in the middle as much as possible and not to the edge. Okay, so we're going to find out. This is where magnetic north is. Magnetic north is this way. It's the military compass. Military, like, I got to add an Army Navy, sir. And, okay, this way is magnetic north. Okay. And let's see, this is the you see something here? Okay, the compass is pointing towards the water. Okay, this one here, magnetic north, is that way. Here's the compass. Okay, so we put a compass to another compass, and alright, it's pointing toward that compass, and here it's pointing towards this one, okay? Now, here, Chloe's gonna hold this. Chloe's gonna hold that right here. And this magnet, we're gonna take this magnet and we're gonna bring this, see the magnet, it's following this, right? So right here. Okay, now what do I wanna do with the kids is I wanna see if we can mark where north is on the paper, on the lid of the, so we know exactly where north is. So if it starts moving from north, we know something is happening, okay? See right here, this is the magnet, this is a magnet, and what's going on is that we are trying to see if I can conduct a test to see if there's any pull from the sun or the moon in terms of magnetism right now. Okay, so right now, let's see, right now I'm going to just show you the magnet. This is the magnet pulling this way, magnet this way, right? Strong magnet pulling this way. Now I'm going to let it go. Let it go and see if it can just go back to its own magnetic north, right? And what I do is that we put like two-thirds, which is like we did 12 tablespoons of salt into this container of water. So it's 2/3 filled. This one here has no salt in it whatsoever. Okay?
So what will exactly happen now?
Well, I don't know. I'm trying to see if there's any magnetism in the water, because they say that the salt water conducts electricity. So I want to see if there's any kind of movement or motion or anything. You know, in terms of like,
will the styrofoam move over somewhere?
Will the styrofoam move? Because look, if I take the magnet and I take the magnet to it, it's gonna move it, right? It'll move it, right? So now, if I take this one too, it'll move it because it's magnets, right? Yeah. And so I have a compass here, trying to see if there's any kind of differential to where we are at. So that's why I wanted to make sure and see if that's any kind of a, you know, change, any kind of change at all.
You should have marked it in.
Let's see if we can mark it still. Let's figure out which side is what. So we know that if this is the magnet's pointing that way, we know that this is a south-facing magnet pointing to the north. It's a south faces north, right? Yeah. So we know this magnet, this side of the magnet must either, let's see, this is south-facing, looking for north, and this is north, right? So this is south-facing north. So this is the north. So this is the north side magnet. So now we know this is north. And that one, that's the south side magnet because it's attracting, right? So opposites attract. With this one too, it also attracts. So both magnets are facing the right. So both of them are south-facing magnets looking for things in the north, okay? So if we leave this, eventually it's going to pull to the north, right? Eventually this one's going to pull to the north too. My goal is wondering if it's going to pull back and go in concert with the sun and the moon as they're pulling. See if there's any magnetic pull of that, you know? So that's what I'm trying to figure out. Okay, I'm going to pause it for a second. Okay, so what I'm doing right now, I'm trying to conduct a test to see whether or not there is a change. So what we did was that here's Brownie Rex right here. I have a compass, and the compass, when you take it away from any other magnetic source, it'll point in a certain direction, right? Let me see, let's let it point over flat, and there it'll automatically line up with the North Pole, which is the center. So what I did, I took the liberty to mark this location here, right? It's the exact same one when you have it in terms of the north and south, in terms of the magnetic pole. Right? So here you have this. When I bring close to salt water, it kind of shifts a little bit. So here we go. This is here. Gently flat. Right? And it turns a little bit. It's moving towards that way. So all things being equal, this way is north. Okay? I'm going to put this over here. Next thing I'm going to open this up and see if we can line this up here. Because my goal, I'm trying to see if there's a difference or a pull in terms of the sun. And this is on a saltwater mix. It's making the water more conductive. It is going to turn to face the sun. Now I'm going to put it all the way over here and see, because I want to make sure that if this is possible, like a compass, that it will affect itself. I'm going to take, I have another magnet here. I'm going to move it further away so that it's not affecting each other, right? I'm going to turn this also to see if there's any kind of change. Okay, if it's going to turn on its own. So my goal also is to keep it as far in the center as possible. So here, this one is turned, and this one here, keep it in the center. Because if it's in the center, it's not going to run into the edges. You know what I'm going to do? I'm actually going to do something, maybe it's a little easier to have mass displays if I use a smaller one instead of the bigger one. So I'm going to put this over here, take this out of the mix. I'm going to put this one here, and put this in the mix to see if the magnetic mix is different if I use a bigger range, right? If I use bigger and a smaller, it might work a little bit better, because I mean less mass to touch. So here it is, and I'm not sure if it's turning because of the sun or the moon. I'm just trying to see, maybe it's turning because my orientation is wrong. I'm trying not to make the wind mess with it. So let's see. I know water always seeks level, so I'm going to close up this thing here. Close this up. I'm going to seal that in there, so there's no wind pushing it. Right? Keep it as far in the center as possible, and see where it turns. Alright, now I can't tell if this is exclusive or not, so I'm going to go ahead and mix it up again. So turn this here. Alright, and see to get it as still as possible. Turn this around. Maybe the magnet orientation needs to be fixed, so let's go ahead and check the orientation of the magnet. Alright, let's see. This is like subtract, right? So this is this to that, right? This is north facing south, so the compass is reversed, so that you know that south is actually north. So that's south. I'm trying to find north. So this here is this side here of the compass of the magnet is actually the north side, and this is the south side. So if you want south to find south, you got to put it face down. South to find north, right? So here we go. I'll put it in here. Do my best to make sure this thing is as balanced as possible. Right? And I'm going to let it sit in the center. And I'm going to close up this thing here. We know that way is north. This way the wind is not going to push it or anything like that. It's going to stay in the center. And now we know it's going to look for the north. Okay, there's something up. It's like it wants to go to this, even there's no reason for it to go. So I'm gonna see, maybe the way it is leaning, so it's causing it one to go that way. So let's try it this way.
Daddy, I have to watch it.
Okay.
It's not watching.
Alright, so it went all the way from one side to the other. Now there's no magnets over there, so I don't know what's up. Let's try this over here again. Put it all the way over here. Alright, we're going to have it facing away from north. So we know north is that way, facing this way. I'm going to put it this way. And north is that way. Okay? North is this way. So I'm going to rest this jammy right here. Down. There's no magnets. No metal, anything. So north is, just going to change the, rotate this a little here, rotate this one here so we can see that it, Alright, so let's see. Maybe, let's see if we orientate it this way. If it's pointing that way, let's go ahead and not move the magnet, but let's move the dirt right here. Face that way so we can get it completely oriented. Facing this way. Alright, so this should be equal with that, right? They should actually line up together. They should be both lined up. Right? So we made a salty mix. With the salty mix, let's see, we did a 12 teaspoons, 1 tablespoon of salt in this water to match this, right? Now I'm going to turn it and see if there's any effect, right? Because now we have it all perfectly lined up and the magnet's facing north and all that jazz. So let's see if it turns back on its own. I'm going to close it so that it's not going to be affected by this. You could turn it a little bit. Alright, keep it right here. Oh no, it's off-centered. Oh, it fell in. Alright, so we gotta figure out which side it is now. This side lights repel, lights attract, right? So lights attract, so lights attract, and this is the south, and this is the south. What's north? Okay, cool. So this might actually work. Alright, so we're going to take this for a second, pick this up, and we're going to orientate this in the right way. So make this sure this is pointing to north. The north is that way. Right? And we're going to drop this magnet. It would be good if I marked this magnet, you know. That'd be a good idea. Alright, let's see. Put it here, right on the point. That way. Right here. Right? So that way. So everything is lined up. I'll try not to hit this side of the thing again. But there it is, facing the same direction. Now if we leave it, not to mess with anything, is it going to turn to orient itself in line with the sun on the moon. And there it is hooking to the side of the plastic. Alright, let's try this experiment one more time. Let's see if we can move it over a little bit. Okay, good. Put the surface tension to bring it to the other side. Okay, so here's that. Alright, I'll leave that jammy there. Hopefully it stays put. I'm going to shake it. If it stays exactly centered, that'd be great. You know, I have another idea. My other idea is this. Let me see. Let me pause it for a second. If I was to take the magnet and to cut the magnet and stick it in straight up and down like this, would it be a better way of testing? I'll give it a try. Okay, so what I decided to do was this. Instead of having the magnet lie flat, I said let me make the magnet stand up on its edge. That way we can know whether or not, right off the bat, if this magnet is going to be affecting, let's see, for example, likes repel, likes attract, likes repel, right? So now we know if this one is, again, if the north is pointing to that one, that means it's south, right? So this is the south magnet. The compass is south, heading for north, right? So then we know that this is north. This is north, and then this is south. So south is always going to search for north, right? So south will search for south, right? And north will search for north. So we know that way is north. So what I'm going to do, I'm going to take this, I'm going to put this into this container, and we know that this way is north, right? We know that's north. So what I was trying to do is to see if I turn this south, would it automatically on its own turn back north? Do that really fast. Alright, almost a little too fast. Okay, so this is the thing, alright, there, and it turned back very fast. Okay, let's try it again, just to make sure that I'm not messing with this, I'm not messing this up anyway, that way, and it turned back north. Okay, so this test is actually very conclusive. Can you see this? Can you actually see it? Okay, let me just bring it a little closer. Alright, I'm going to turn it again, right? So in essence, I just made my own compass. Kids, come see this real quick. Alright, what I want to share with you is quick, is like right here, I made my own compass. I use a magnet, put it on this edge. I find out which way is magnetic north, and this way points to magnetic north, which means this is south, trying to find north, right? So I put this in the water, and here, if I drop it, it should actually turn back to north. And as you can see, it's actually doing that. So there you have it, it's doing that, right? It's pointing towards the north. My goal was to see if I turned it around like, and so pretty much I wanted to see if this would affect, and here am I turning this, and you see the arrow is pointing away, and arrow is pointing away, and there it is pointing towards the north. This is north, right? So here you go, this, I'm going to turn it, right, and it's on a saltwater mix, here, and it turned back again. And one more time, I'm going to turn it back again, that's turned away, and it turned back to north again. So now my goal was to find out if there was any magnetic or more magnetic pull on the sun, because this water is salt water. It's more salt water than anything else. It's a saltwater solution. And I turned it, put it here, and I have this on a styrofoam floating block, here, a piece of styrofoam. And I have it, and when I take it and let it go, and there's no wind to affect it, it turns back to magnetic north. That's what I wanted to share with you on that.